Okay, today we are talking about probability of multiple disjoint and non-disjoint events. 10.4. Okay, does anybody know what disjoint would mean? What? What does joint mean? Connected. So disjoint would mean? You guys are amazing. That's exactly it. Okay. So disjoint events, or sometimes they're called mutually exclusive, are two events that have no common outcomes. So it's just asking you about two different probabilities, and there's no overlapping at all. And so all you're going to do is multiply the two probabilities together. Okay? If that's when it's and. If it's or, you're going to add the two events. That's it. We're going to do some examples now. Okay. Example 1. A bag contains 6 white, 3 blue, and 7 green marbles. If 2 marbles are chosen at random, what is the probability of each event? Okay, so how many total marbles do we have?
16.
There are a total of 16. So I always kind of like to write that. Okay. So it's not telling you that they're choosing a marble and putting it back in the bag. So if they're saying that they're choosing 2 marbles, that means you're actually taking 2 marbles out of the bag. So you're going to take 1 marble out of the bag, and then you're going to take a second one out of the bag. Okay? If you don't see the word or, it's an and problem. Okay? So both are white. So how many whites are there to begin with? 6 out of 16. We take out a white. Now how many?
5.
Out of how many?
16. Oh, 15.
15, because there's 1 less white and there's 1 less total marble. Because 1 is now out of the bag, there's now only 15 to choose from. Does that make sense? Okay, and then you're just going to multiply these together. If you can reduce it all, I suggest reducing before you multiply because it'll make things easier. So for instance, when I look at this, I know that 5 and 15 are, they can go into each other. So 5 becomes 1, 15 becomes 3. Okay, do you notice anything else that can reduce?
Yeah, 6 and 16 divided by 2.
Okay, you can divide by 2 to 6 and 16, so that would make this 3 and this 8, and then both of the 3's can cancel out. You can reduce things more than once, right? It's just anything on the top can reduce with anything on the bottom. So both these 3's can cancel out and become 1, and so I end up with the answer of 1 over 8. Okay, we should have our notes out, please. Okay, B, both are green. Okay, I'm going to give you about 30 seconds to try B on your own.
Okay, B now.
Wait, could you reduce like a 16 and an 8 if they're both on the bottom?
Yeah, so remember when you're reducing, it has to be 1 on the top, 1 on the bottom. Okay, so both are green. What's the first fraction?
7 over 16.
Good, 7 over 16. And then we take 1 out and we have what?
6 over 15.
6 over 15. And can anything reduce?
6 and 15.
Okay, 6 and 15 we can divide by 3. So I end up with 2 over 5. Can anything else reduce? 2 and 16. So 2 becomes 1 and 16 becomes 8. Can anything else reduce? No. I did, yeah. We did 3 first, so when I did 6 divided by 3, it became 2. 15 divided by 3 is 5. And then the 2 and 16, I did it. If you did the 2 and 16 first, that's fine. Then you'd have a 3, and you'd still do the 3 and the 15. Okay, either way, though, you'll end up with the same answer, and you get 7 on the top and 40 on the bottom. Okay. Example 2. A card is drawn from an ordinary deck of cards. Find these probabilities. Okay, so notice here how it has or. The probability of getting a jack or a six of clubs. What it means is you're only taking one card. So you're going to find out the probability of one event and the probability of the other event, and you're adding them together. Notice on this one how you're taking two marbles. Two things happened, okay? This one, two things aren't happening. There's just different options, okay? So what's the probability of getting a jack?
4 out of 52.
4 out of 52. And then with or, we add those together. And then how many six of clubs are there?
1 out of 52.
1 out of 52. And we add those together, and I get
52.
5 out of 52. And can that reduce?
No.
No. So that's my answer. Okay, you do B.
Diamond or club? Well,
Oh, remember, and I don't know, I'll write these up here, but there are
52 cards.
total of 52 cards. There are 13 cards in each suit.
So then it's exactly half. So then it's probably just going to be more. Right. Alright, so the second one.
And I will leave this up when you guys are taking your test, because you shouldn't have to know cards in order to do the problems. You know what I mean? For those of you that don't know how to do or don't know cards. Okay, so how many diamonds are there? Good, 13 out of 52. And how many clubs are there? 13 out of 52, which makes 26 out of 52, and that reduces to become 1/2. Okay, are we good so far? All right, example 3. Sonia is moving, and all of her CDs are mixed up in a box. 12 CDs are rock. Okay, so we have 12. Okay. 8 are jazz, and 5 are classical. If she reaches in the box and selects 3 at random, so how many is she taking out?
3.
3. So if she's getting 3 things, we're going to end up
Multiplying.
multiplying them, because we're not doing one event, right? Okay. It says find the probability of each. So first of all, how many total CDs are there?
Well, there's going to be 12.
Good. No.
25.
Thank you. 25 is correct. 12 plus 8 plus 5. Okay, so there's a total of 25. So she's taking out 3. Sometimes I will, to remind myself, I'm going to make 3 blanks like that, or kind of like my fraction signs. So it says the probability all of them are jazz. So how many jazz are there?
8.
8 out of 25. We take one out. Now there are,
7 out of 24.
and then there are.
Times 23.
Okay? And so now we will reduce as much as we can.
Oh yeah, the 8 and the 24.
Okay? And basically, because we could do 6 and 24 or 8 and 24, right?
Do the 8.
Okay? So it's up to you, but we'll go ahead and do the 8. That becomes 1. 24 becomes 3. Can anything else reduce? Good. 3 becomes 1, and 6 becomes 2. Do we see anything else? No. And if you want to, go through and circle each of your numbers on top and on the bottom so that you're not like missing anything, because I think sometimes that's what happens is you don't realize there's a number there. So we multiply those together and we end up with 14 over 575.
And that's for jazz only.
For only jazz. Okay, now you're going to do rock on your own.
That's for rock. And that's going to be 12
Okay, so how many total rock are there? 12 out of 25. We choose one, and now we have 11 out of 24, and we choose one, and we have. Perfect. Okay, what do we notice Kim reduce? Okay, 12 and 24. So 12 becomes 1, 24 becomes 2. What else? Okay, 2 becomes a 1, 10 becomes a 5.
And 5 and 25.
Good. 5 becomes 1, and 25 becomes 5. So all I have on top left is an 11. And on the bottom I have a 5 and a 23. And you multiply that together and you get 115. Okay, questions? Okay, so these were disjoint events, kind of, where they don't affect each other, okay, because they're separate events. Now we are going to move on to non-disjoint, which means that they are joining. Does that make sense what I'm saying? If you were to draw a picture, it's like a Venn diagram. So the events overlap. Exactly. I don't know, because they want to confuse you. Okay. All right, so they're overlapping if they have one or more outcomes in common. So what ends up happening is that you add the two events together, but you have to subtract out where they overlap. So so it's like I'm adding A and B. If this was event A here and this is event B, the probability of A plus B, but then I have to subtract out this little thing in the middle because you can't overlap them. Okay, so you have to, because otherwise you've been adding them 2 times and you should only add them once. This will all make sense when we do some examples. Then there's complementary events that are opposites. So here's your examples. These are opposite events. You know, rain, no rain, male, female, true, false, win, loss, even, odd. They're exact opposites of each other. So that means they're complements of each other if there's an exact opposite. Okay? The probability of an event happening and the probability of the event not happening should be able to add together and equal 1. It's either going to happen or not happen. There's no in between, right? Does that make sense?
Yeah.
Yes? Okay. All right. Example 4. A card is drawn from an ordinary deck of cards. Find these probabilities. Okay. So the things you want to pay attention to are your ors and your ands. Okay. So when we see or, we're going to end up adding, and we see and, we're going to multiply. Okay, so it says a queen or a heart. Okay, so when you look through, and sometimes looking up here, it's easy to see on the board where I have it all written down. And if you want to take a picture of it on your phone so that you have it at home to look at, you can. But how many queens are there in a deck of cards?
4.
Okay, so there's 4 out of 52. Do we all agree? Okay, and then how many hearts are there?
13.
There are 13 hearts out of 52. Now, did those overlap? Do queens and hearts overlap?
Yeah.
Yes, because if you look here, okay, oops, we have our queens, right? There's 4 of them, and then we had our hearts, and so they overlapped by how many? 1. So I added this queen 2 times, but there's really only 1 queen,
Teachers
right?
and students, please excuse the interruption. At this time, all seniors that have signed up for the community college with the last name beginning A through J, please report to the MTR immediately. All seniors that have signed up for the community college with the last names beginning A through J, please report to the MTR. Thank you.
Okay, so we have to take one of the queens out because there's really only 1 queen of hearts, but I added the queen of hearts 2 times. Do you guys get what I'm saying? Because we added the queens with the queens, right? There was 4 of them. And then I added the queen again when I added all of the hearts. But there aren't 2 queen of hearts. There's really only 1 queen of hearts, right? Are you guys with me? Are some of you still confused? Can somebody try to explain what I just said? So, because maybe it'll make more sense if somebody else says it differently. Okay, Marcus, try to explain.
I actually have a question. Instead of 4, can you put 3 because you're taking 1 out?
You can do it however it makes sense to you. So, because when we're seeing if an event will happen, it's wanting to see what's the probability of drawing either a queen or a heart. They want either a queen or a heart, okay? So if I add the queens, there's 1, 2, 3, 4 queens. If I go down here and add all the hearts, there's 13. But I already added this queen, so I can't add that queen again. And so that's why I have to take it out. Because otherwise I'm saying there's 2 queen of hearts in the deck, and there aren't 2 queen of hearts. There's only 1 queen of hearts. Okay? Are we good now? Okay. All right, so then 4 plus 13 is 17 minus 1 is 16 out of 52, and then you want to reduce. Since these are both even numbers, I know I can divide by 2, and if you want to just divide by 2 and see what happens. So if I divide by 2, I end up getting 8 over 26. I can divide by 2 again, and I get 4 over 13.
So that's your answer.
That's my answer.
On the test, will you have to reduce?
Yes. Yeah, you always want to reduce. That's weird. Okay, a queen and a heart. So this one is slightly different because it says and. So that means they're choosing. There's like kind of two things that are happening. So and we're going to multiply. I don't need to worry about subtracting anything. The only time you have to worry about subtracting is when you're adding. Okay, so how many queens are there? 4 out of 52. And a heart, how many hearts are there? 13 out of 52. So again, the only time you have to worry about subtracting is if you're adding. And then can I reduce here? Okay, so 13 goes into 52. So 13 divides into 52 4 times, right? What? And then 4 divided by 4, those are 1, so we get 1 out of 52. So let's think about this, okay? We're going to kind of go backwards. What's the probability of drawing a queen and a heart at the same time? A queen and a heart at the same time. There's only one card that's a queen and a heart. The Queen of Hearts, right? Which would make sense why it is 1 out of 52. Make sense?
So if you know your cards, you could have just got
Exactly. But this is how it goes mathematically. Okay? Are we good? Yes? You say you're still confused? So, if queen and a heart, they're saying, what's the probability of picking a card out that's a queen and also a heart? A queen and also a heart. There's only one card that is a queen and a heart, which is why we ended up with 1 out, because 1 out of 52 cards are queen and a heart. But this is how you do it mathematically. There are 4 queens, 13 hearts, we reduce, and you get the same answer. Okay? Yes?
So, like, for this question, we just have to use a word? Or
No.
just have to figure it out?
You can kind of figure it out. Yeah. Okay. Now we have a queen or a jack. Would you say these are joint events or disjoint events? Good. They're separate. So am I going to have to subtract anything on this? No, because there's no overlapping part. The only time you subtract is if there's overlapping. So how many queens are there? 4 out of 52. And how many jacks are there? 4 out of 52. And queens and jacks do not overlap. So I get 8 out of 52. Which I can reduce. If I divide by 2, I get 4 over 26, and I divide by 2 again, and I get 2 over 13.
I'm gonna get these notes in.
Okay, D. A 10 or a 9. Am I going to add or multiply here? How many 10s are there? 4 out of?
52.
How many 9s are there?
4.
4 out of 52. Do these overlap at all?
No.
So I end up with 8 over 52, and I already know that this reduces to what? 2 over 13. Okay,
4 over 50.
hold on.
Wait,
Hold on.
that's 50.
Okay, so E, a 5 and a black card. Now, 5s and black cards do overlap, right? But does it matter in an and problem? No. Okay, so how many 5s are there? 4 out of 52, and means multiply. How many black cards are there? 26 out of 52. Okay? And so now we're going to go through and reduce. 26 and 52, I get 1 over 2. 4 and 52, I reduce, and I get 1 over 13, and I multiply, and I get 1 over 26. Now, if we go backwards and think about it, how many cards are 5 and also black? 2. Okay? Right here. These 2. There's 2 5s that are black out of 52 cards, which reduces to 1 over 26.
So why don't we do it that way?
Because I'm showing you the whole mathematical process as it. But you could do it either way. Okay? All right. The probability that something is not a club. Good. There are 39 out of 52 cards that are not a club. Okay? And then that would reduce to what?
13.
Good. Or 3/4. That's it.
13 over 52.
39 out of, not a club. So everything except for clubs. So you'd add 13 hearts, 13 diamonds, 13 clubs. I mean, not clubs, spades.